Unit 5, Part 6. So I was talking about the complications of calculating the truth value columns when you have sub-formulas that have some complexity. So we haven't quite seen that yet, right? So here, that's as complicated as we've done so far. A hook, it's complex, right? It's not a simple statement, it's not just P, but the components are both simple, P and Q. Here we have a disjunction where the right disjunct is a negation, right? So already has some complexity. That means we have to calculate the truth value column for the subformula before we calculate the truth value column for the formula as a whole, right? The formula as a whole, that refers to what's the major operator, right? The major operator, this is, what is the form of this thing? It is a disjunction, right? We said that in the last part. This is a disjunction, it's so you're gonna have a column that appears under the negation, which will be the column for the subformula that is the second disjunct of the overall disjunction. And with that in hand, you will be able to compute the truth value of the formula as a whole, the statement form as a whole, that is the disjunction. But when you become a terminator, you have to be a sophisticated terminator. Why are you a terminator? You're testing the argument form for validity. It amounts to seeing whether there are or are not any counterexamples. A counterexample is this. So that's what you're looking to match. You're seeing if any beep, 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 any of the rows match this, right? All premises true and conclusion false. Make sure you have it right in your head. Don't think you're a terrible terminator if you think it's false, false, true, or anything like that. No, it's all premises true and conclusion false. Make sure you have that straight. When you're so you become the terminator after all the truth values are computed, but you've got to make sure you look in the right place, right? It's true, true, false that you want to match, but T's and F's here under the negation sign, they're not going to matter, right? It's got to be it's got to be, well, since this is a premise, this would have to be true to get a counterexample, but it's going to be true under the major operator, right? So sometimes when you have lots of T's and F's appearing here, when you've got to calculate subformulas that have complexity, right? You've got to make sure that you're looking, that your eyes, this is your eyes are in the right place, right? Looking at the truth value column under the major operator of the statement form, not at the columns that will appear under the subformulas, okay? That's very important, right? There's a T here, doesn't matter. Don't think, oh, there's a T here, this might be a counterexample. And, it's not that you'd think that, it's that you unthinkingly would do that, not being aware of this possible error. It's got to be a T here. This can be false, false. It might be false, false, but this is true. Oh, okay, yes, that could be a counterexample. Okay, so let's do it. Let's compute it. So first I compute not Q, because I need to know the truth value for each row of not Q in order to then be able to compute the truth value of P or not Q. Not Q is just the opposite of Q, so it's false, true, simple. If any of this stuff confuses you, they're just simple applications of the truth tables introduced in Unit 2, I think, or Unit 3, Unit 2, right? Or was it 3? Anyway, Unit 2 or Unit 3, the truth tables are introduced. We're just applying those truth tables, right? Disjunction, right? Remember, and it's good to be able to say it, the disjunction is true in all cases except where both disjuncts are false, right? So it's only false when both disjuncts are false, true in all other cases, right? What am I looking at? So notice where your attention goes, right? You're applying the truth table knowledge for the wedge, for the disjunction, but it's P and not Q. So your attention is, this is the P and this is the not Q. So I'm looking at true or false. That's true. True or true is true. False or false is false, right? That's the one case where it's false. False, wedge, false becomes false. And here, false, wedge, true, that's true. That makes it true, right? You could have, of course, done a shortcut. Since it's true here, you could write true straight away there. True there, you could write true straight away there because the truth of one disjunct suffices for the truth of the disjunction. Could have looked here and write them both down. Okay, the biconditional, you should know the truth table of the biconditional is just true, false, false, true. Right? True when they have the same truth value, be it true or false. False when they have different truth values. Okay, so that's my column. And as I say, you might want to, right, maybe you'll do this in a different color or something, but make sure, see here, we've got two columns. Your attention has to be on the right one. It's got to be true here to be a counterexample. Okay, so let's see. Now we're becoming Terminator, inspecting row by row. Do I have one of these? Do I have a TTF anywhere? Where the premise is true, conclusion's false. What have I got? TT, oh, this might be it. No, TTT. True premises, true conclusion, not a counterexample. False, okay, so this isn't it. Because we don't have, since this is false, we don't have true, true, false. Here we've got true, false, false. No, we don't have all premises true because the second premise is false. True, true, surely this is it? No, true, true, true. Okay, what's the conclusion? The conclusion, when in a case like this, you say, oh look, this argument form doesn't have any counterexamples. Right? There are no substitution instances, no, what is a substitution instance? This is another important statement of what a substitution instance is. A substitution is an assignment. One definition, a substitution instance is a row in a truth table. Another one is a substitution instance is an assignment of truth values to the sentential variables. So we can talk of the substitution instance where, say, P is true and Q is false. Right? That'll be a good way of understanding it for the short truth table method, which I'll do in a bit. Okay, so this argument form is such that there are no substitution instances where the premises are true and the conclusion false, right? And here we can say, right, therefore the argument is valid, right? So this is the first one you've seen where you've been able to make that grand conclusion that we were aiming for in Unit 1 and finally have arrived at the ability to do. You'll be able to say, right, because of the truth functionality stuff, as I was explaining in the first parts, because these base columns list everything that goes into determining the truth value of the sentence forms. Since there are no counterexamples here in this truth table, and since the infinite number of possible substitution instances has, through truth functionality, been gathered into this exhaustive column of possible truth value combinations, because of that, when no counterexample appears here, we can say this argument, the truth table for this argument form presents us with no counterexamples, therefore no counterexamples exist, therefore this argument form is in fact valid. All you have to say in the exam is there are no counterexamples, therefore the argument form is valid.